Let's practice some concepts in the number system today. Before that, let's do a quick recap of what we have learned. Here is the number system. We have natural numbers, which are the numbers we use for counting. We have the whole numbers, which are natural numbers. Additionally, we have zero. We have integers, which are whole numbers, and also the negative whole numbers. We have rational numbers, which is a bigger superset. The numbers which can be expressed in the form of fractions. Or decimals. We have a decimal here, which is a recurring decimal which repeats itself. We also have a decimal which is a terminating decimal, which means it has finite number of decimal places. This is a terminating decimal. It stops at one point. We have a number set which is different from all these numbers we have seen. That is irrational numbers. It represents all the numbers which are not rational, that means which cannot be expressed in the form of a fraction. We have a decimal here which has infinite number of decimal places. There is no end to it. It doesn't terminate. This is an irrational number. Pi is also an irrational number. No one knows how many decimals it has. We also have square roots of imperfect squares. The result is also an irrational number. If we take square roots of perfect squares, the result is a rational number. For example, square root of 4 is 2. This is a rational number. We have real numbers here, which is the bigger set. All the numbers we have discussed so far fall into the category of real numbers. Let's go into the practice. Can you place 7 in the number system? It can belong to more than one group. Can you place -7 in the number system? It should belong to integers and also rational numbers. Can you place 0 in the number system? 0 is a whole number. It is an integer. It is also a rational number. Can you place -35? -35 is an integer. It is also a rational number, but it is not a whole number. It is not a natural number. Can you place half in the number system? Half is a number that can be expressed as a fraction. This is a rational number. It's not a whole number, not an integer. Minus half is also a rational number. Rational numbers can be negative also. Not an integer. Can you place -3/4? Minus a fraction. This is also a rational number, but definitely not integer or whole number. 0.75, a decimal with finite terminating decimal values. is also a rational number. Minus 0.75 minus a decimal with terminating decimal values. A rational number. Rational numbers can be negative also. Root 64, this is a perfect square. The answer is 8. So it is a rational number. Perfect squares are rational numbers. So 8 is also an integer, a whole number. Root 100 is also 10. Perfect square, a rational number, an integer, a whole number, a natural number. It belongs in all these categories. Minus square root of 100, that means minus 10. Minus 10 is an integer. It is also a rational number. It's not a whole number. Minus square root of 2. Square root of 2 is a decimal with infinite decimal places. It doesn't have an end, so it's an irrational number. It's not a perfect square. Square root of 2, again, it's not a perfect square, so square root of 2 is irrational. What is the product of two irrational numbers? Let's see. Let's take examples. We have square root of 2 and square root of 2, both irrational numbers, and the result is 2. This is a rational number. So in this case, this is a rational number. Let's take one more example. Pi and pi, these are two irrational numbers. The answer is also an irrational number. You are multiplying two undefined values, two vague numbers to get a vague number. So this is irrational. So the answer is, we can't say what the product is, whether the product is rational or irrational. So the answer is this. We can say the product of two irrational numbers. Now the sum of two irrational numbers here. Let's see examples. We have root 2 and minus root 2. These are two irrational numbers. We are adding them up. The answer is 0, which is a rational number. Let's take another example. We have root 2 and root 3. Both are vague numbers, undefined numbers. So this is irrational. The sum is also irrational. So we can't say. So whatever we do with two irrational numbers, the result is undetermined. The sum of a rational number and irrational number is irrational. Let's see how. We have 2 and root 2, a rational and irrational. We have 1 and pi, both are irrational numbers, which means both give us decimals with undefined values or never terminating numbers. The product is also the same way. It's irrational. The sum and product of a rational and irrational number is always irrational. Let's reiterate this point. Irrational and irrational numbers, we are doing something with them. We can't say the result. Is the following diagram correct? Integers is a subset of whole numbers. This is wrong. Minus 2 can be placed in both integers and rational numbers.